This is page 15 from chapter 6. Y equals cosecant of pi over 2, or theta over 2 minus pi over 4 plus 2. First thing I'm going to do is rewrite this. That's cosecant. What I could do is pull out a 1/2 in front, so it's in better form, and I'm left with theta minus 1/2 times pi over 2 is pi over 4 plus 2. So this is equivalent. It's going to be easier to graph. So what I'm going to do is this. There's no amplitude here, but the period's going to be 2 pi divided by 1/2. So the period is 4 pi. So your basic 4 points are 0 or 5 points, 0 pi, 2 pi, 3 pi, and 4 pi. What I need to do to all of them, there's a phase shift of pi over 2, is add pi over 2 to each of these. So if I do that, my new points are pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and 9 pi over 2. And then I'm going to put a 1 and -1. I do know that there's a vertical shift of 2. So what I can do is this. I'm going to first graph the sine graph, and then the cosecant graph's the reciprocal. So the normal sine graph starts at 0, then up to the maximum, then 0, minimum, and 0. So I'm going to graph this in red. The reciprocal of any 0 would just be undefined. So that would be vertical asymptote here as well. Here as well. And then what I can do is this. The reciprocal of 1 is 1. The reciprocal of -1 is -1. If there was no vertical shift, the graph is just going to go away from the sine graph. It's going to go up like this and down like this. So I'm going to do the same thing, but I just have to push it up 2. So it's going to look like this. And then if I go up 2, it's going to look like this. That would be example 3. The next one below here would be this. Y equals secant of 2 theta minus pi over 2 plus 1. I'm going to rewrite it. I can pull out a 2. I'm left with theta minus 2 times pi over 4 would be pi over 2 plus 1. So that's going to be in better form. The period is 2 pi over 2, which is pi. There's no amplitude. The phase shift is pi over 4. And the vertical shift is 1. So my 5 main points would be these points up to pi. And then I've got to add pi over 4 to each of these. So if I carefully add pi over 4 to each, I get pi over 4, pi over 2, 3 pi over 4, pi, and 5 pi over 4. And then what I can do is this. Secant's the reciprocal of cosine. So your normal cosine graph would look like this. 1, 0, -1, 0, and 1. Then secant's the reciprocal. So the reciprocal of 0 is undefined. The reciprocal of 1 is 1. Reciprocal of -1 is -1. And the reciprocal of 1 is 1. If there was no vertical shift, it would just go away from the normal cosine graph like that, and down here. So we're going to do the same thing, but just push it up 1. So up 1 and then towards the asymptote. Up 1 towards the asymptote. Up 1 and away from the basic cosine graph like this. So that would be this example. Y equals secant of 2 theta minus pi over 2 plus 1. Bottom of the page, write an equation for the given function. Secant with period pi. Y equals secant. If the period's pi, 2 pi over blank equals pi, that would be 2. And if the phase shift is pi over 3, it'd just be theta minus pi over 3. That would cause the graph to go pi over 3 to the right And the vertical shift is -3, so I would just subtract 3. That would be the first part. Second part, cosecant with period 3 pi, y equals cosecant, 2 pi over b if I set it equal to 3 pi. If I solve for b, I would get 2/3. And then I'm left with theta minus pi over 2, because the phase shift's pi over 2 plus 2. So that would be these two on the bottom. So these are the notes from page 15 from chapter 6.